Assalamu alaikum and good afternoon. My name is Nahin Chaudhary and today I will be talking about a very secure form of encryption tool. The algorithm which I'll talk about is Serpent Cipher. I'll highlight three aspects of this algorithm: what it is, how it works, and how secure it is. So, what is a Serpent Cipher? A Serpent Cipher is a symmetry key block cipher, which means it uses the same key for encryption and decryption. It is also a block cipher, which means it uses 128-bit block of plaintext as input and outputs a 128-bit block of ciphertext. This cipher is a 32-round substitution permutation network. This algorithm was developed by Ross Anderson, Eli Behan, and Lars Knudsen. Now, how does a Serpent Cipher works? The Serpent Cipher is made up of 5 components. At first, we have the key schedule, where 33 keys are produced. Then, the plaintext goes through an initial permutation. After that, the key and input go through 32 rounds of S-boxes, followed by linear transformation. And finally, in the last round, a final permutation produces the required ciphertext. Now I'll talk about each of the components in details. Key schedule. The Serpent Cipher supports a key size of 128, 192, or 256 bits. In my example, let's assume we are using 256 bits key. The main purpose of key schedule is to convert a key, the secret key, into 33 subkeys. These 33 keys are used in each round to encrypt the data. The 33 keys are produced by taking the secret key as 8 32-bit words and expand this into an intermediate key, which we call pre-key. These pre-keys are XORed with phi, which is the fractional part of the golden ratio, and round index I is chosen to ensure an even distribution of keys. The result of the XOR operation is rotated to left by 11. The initial and final permutation do not have any cryptographic significance. They are used to simplify and optimize the implementation of the cipher and to improve its computational efficiency. The linear permutation is applied to the plaintext, which is the input of the first round, and after the output of the 32nd round, or in the last round, the final permutation is now applied to give the ciphertext. The Serpent S-boxes are based on DES S-box. The 128-bit combination of input and key is considered as 4 32-bit words. The Serpent S-boxes are 4-bit permutations. So, after a sequence of logical operations is applied to these 4 words, and the result is 4 output words. In this way, the hardware can run 32 copies of S-boxes simultaneously. Then, linear transformation is applied to the 4 32-bit words we got from the S-boxes. The reason for which linear transformation is done is to maximize the avalanche effect. It consists of XOR, bit shift left, and bit rotate left operations. The 32-bit in each of the output words are linearly mixed. Here, the 3 greater than sign denotes rotation and 2 greater than sign denotes shift. However, in the last round, this linear transformation is replaced by an additional key mixing. This figure shows how a Serpent Cipher works with all of the components together. Here, at first, the plaintext goes through the initial permutation and produces 128-bit data block. Then, it is XORed with one of the subkeys. Then, this combination of input and key goes through the S-box. After coming out of the S-box, it goes through linear transformation. Then, this output is again XORed with another key. This process happens 32 times. Then in the last round, the output bits are again XORed with another subkey, and then it goes through the final permutation. This final permutation is sometimes also known as inverse of initial permutation. Hence, we can see IP inverse 1 here. Finally, we get our ciphertext. How secure is Serpent Cipher? While other algorithms have around 8, 10, or 16 rounds, Serpent Cipher has 32 rounds of SPN, which makes it more secure than other algorithms. Since the key size is 256 bits, so if a supercomputer attempts to crack the key, it would take 9.63 into 10 to the power 52 years to crack. Finally, as the block size is 128 bits, a dictionary attack will require 2 to the power 128 different plaintext to allow the attacker to encrypt or decrypt arbitrary messages under an unknown key. So in terms of security, it is one of the most secure form of encryption algorithm which could serve to protect data for decades. Now I would like to talk about the SWOT analysis of Serpent Cipher. The strength. Although most of the algorithms before were designed primarily for hardware and encryption, yet the great majority of applications that use it today implement it in software, which is the exact reason why Serpent was designed. The Serpent Cipher algorithm has not been patented yet. That means there is no restriction regarding its use. As a result, anyone is free to incorporate Serpent in their own software or hardware if they want to, without paying license fees. Weakness. If we compare Serpent Cipher with the current AES, we'll notice that Serpent is a bit slower since it has 32 rounds, where AES with 10 rounds is faster and easier to implement. Threats. The XSL attack, if effective, would weaken the cipher. Opportunities. Serpent Cipher was the finalist in the AES contest, which proves how much secure and efficient this algorithm really is. This encryption can be used to protect enormous volumes of financial transactions, health records, and government information over a period of decades. That's all about my view on the Serpent Cipher. I hope you enjoyed my presentation.